We're looking at section 3 examples here for lines and triangles. We're going to identify each special segment here in the image. In the first picture we have a triangle with a line dropping from one vertex here, one corner of the triangle, and going down straight to the other side, forming a 90-degree angle when it hits. When you have that, that's called an altitude. One thing that's interesting is there are some triangles, for example, if you had a triangle that looked like this, where if you tried to draw an altitude, a line coming down from this vertex, and it had to form a 90-degree angle, you would actually have it come down here and have it form a 90-degree angle outside the triangle. So that is possible sometimes if the altitude actually is outside the triangle, but typically you'll see it coming down straight like this and form a 90-degree angle inside. Next one, you'll notice that this purple line, pink line, is going straight up and down and is perpendicular to the blue line, the blue base of the triangle. You'll also notice that this side here and this side here are equal pieces. It has a little tick mark on it that says these are equal segments. And so this line, this pink line, is bisecting the base and it's perpendicular. That's why we call this a perpendicular bisector. Perpendicular bisector. Notice how it doesn't have to go through the vertex on the other side. It could, but often will not. Next one down, third one in the picture, we have again two equal segments down here, but this time instead of forming a 90-degree angle here, we don't have a 90-degree angle necessarily, but we do have a pathway to the vertex. So whenever you have a line that goes from the midpoint of one side, D is the midpoint, since these two parts over here are equal, D is the midpoint, so going from the middle of the side to the other vertex, that is called a median. And then finally this last one here, we have no indication that these two are equal. That may be true, but probably is not. From the picture it actually looks like it is not. What we do know that is that the angle up here, angle A, is being split into two angles. So specifically CAB, this big angle, is being cut exactly in half. It is bisected. So we have an angle bisector. So we zoom out, we have our four here. We have an altitude, perpendicular bisector, a median, and an angle bisector. Next one here, this problem's a little ambiguous, so I'm going to actually add a little bit of information to it. It says BE is a median and AE is equal to 9. So we have our triangle over here. We have BE, this line going up and down, is a median. And we're also told that AE, this little part down here, is equal to 9. We want to know what AC is. So let's say find AC. And in order to find AC, what we're going to do is we're going to look at this entirety here. And if BE is a median, if this is truly a median, that means E is the midpoint of AC, because medians always go to the midpoint of that side. So if that is true, then we also know that EC is equal to 9, because it's two equal pieces if that's the midpoint. And if we add those together, we're going to get 18. So AC is what the question is asking here. AC is going to be 18. Scroll on to the second one. It says SB is a median. Find SC if SA is 6. Well, if SA is 6, and if SB is a median, then we know that SB is going to cut this into two equal pieces, making this also 6. So SC, the piece over here, is going to be 6. Finally, number 3, VI is a median. So VI is a median, which means these are cut into two equal pieces. Find X if XW, this whole thing here, is equal to 3x minus 4 I encourage you to always write on these pictures. It's going to help you. And then IW is x plus 1. So IW is x plus 1. So if I know that this is a median, that means that this is split into two equal pieces. And this little piece right here is going to be half of the big one. So if I were to double the little, I'm going to get the big, the whole. So let's write this out now with our actual values we have in here. We have an x plus 1 for the little piece, and I'm going to double that, and that should be equal to the big piece, which is 3x minus 4. I distribute. I clean up my sides. I subtract 2x from both sides, and I add 4 to both sides. And I'm going to get x is equal to 6. And like all good problems, I should always check if I'm doing this right. I plug 6 back in for x, and I would get 3 times 6 minus 4, so that's 18 minus 4 is 14. 6 plus 1 is 7, and 7 should be half of 14, so that's perfect. Continuing on with mid-segments. Now, mid-segments are parts of a triangle where you have, it's the midpoint of each side here, and you draw a line that connects these midpoints together. So P and Q are midpoints of triangle ABC, and if you connect those two together, you get a mid-segment. So connecting midpoints gets you a mid-segment. Now the mid-segment, given that it's halfway up the line, it's also going to be half as long as the side it's parallel to. So you'll notice that this segment is parallel to the base of BC, so x is going to be half of 6, so x is going to equal 3. On this next one, find n. The same idea applies. If we have equal, equal, then this is the midpoint. If we have equal, equal, this is the midpoint, therefore we have a mid-segment. And this piece right here is going to be half of what this piece over here is. So I'm going to take 2 times the little, and that's going to be equal to the big again. So if I double my mid-segment, I'm going to get the whole thing. So 2 times the little in this case is n plus 14, and that's going to equal the big, which is going to be 3n minus 12, or 3n plus 12. Distribute out. 2n plus 28, and then I just need to clean up my algebra here. So I subtract my 2n from both sides, and I subtract 12 from both sides. And as I do that, I'm going to get n is equal to 16. Again, we always want to test this, make sure it works, so I plug in 16 here. 3 times 16 plus 12 is going to be 48 plus 12, which is 60. 16 plus 14 is going to be 30. And 30 is half of 60, so that's exactly right again. Solving angles and triangles. Now, there are shortcuts for these types of problems, and I'm not going to show you how to do it because I think that the shortcuts actually can cause problems later on. If you find that you really do want to know the shortcuts and you feel comfortable with the basic technique well enough that you can take on a shortcut, just ask me about it. I'm happy to tell you. But for now, I'm going to show you maybe the longer way of solving specifically these types of problems here. So we'll start with one. We have a straight line here, and whenever we have a straight line, we know that the total of these angles is going to be 180 degrees. We also have a triangle here, and the total of the 3 angles in every triangle is also going to be 180 degrees. So if I were to take 50 plus x plus y and add them together, it would equal 180. If I were to take 92 plus y and add them together, it would equal 180. So let's go ahead and do this one step at a time. Let's solve for y first, because this triangle has 2 unknowns, and I don't know how to solve for 2 unknowns. I do know how to solve for one thing I don't know at a time, though. So 92 plus y should equal 180 because it forms a linear pair. If I take 92 away from both sides, I'm going to find that y is equal to 88. And I'm going to write that right in here. Now that I know that, I go back to my triangle, and I see that I have 1, 2 of the 3 angles, and I know the 3 add up to 180, so let's add those together. 50 plus 88 plus x equals 180. If I add these together, I get 138 plus x equals 180. And take that away from both sides, and I end up with x is equal to 42. And just to check that this all makes sense, 88 plus 92 does equal 180. 42 plus 50 is 92, and then again plus 88 is 180. So both my triangle and my linear pair here check out. So I'm going to have x equal to 42, y equal to 88. Same idea applies down here, except this time we don't have any solid numbers to solve for anything in particular right away. We have a triangle, 3 angles that add up to 180. We have a straight line, 2 angles that add up to 180. So let's try this out. If I can find this angle here by taking 180 minus this one over here, I can go ahead and solve for what this would be. 180 minus this angle right here, this 3x minus 10, is going to equal this angle over here, this unknown. And if I distribute my negative, I get 180 minus 3x plus 10, because I distribute to both. And then I get 190 minus 3x. Now that's not a number, which can be a little frustrating. But 190 minus 3x is actually the best we can do in this first step to name this angle over here. Now, once we have that in here, let's go ahead and add up the 3 pieces of our triangle to equal 180. So I have 25 plus x plus 15 plus 190 minus 3x. And those 3 angles in my triangle should equal 180. A little bit weird, but let's see if we can make this work. We have our number pieces over here, so 25 and 15 is 40, plus 190 is going to be 230. We also have an x and a minus 3x, so that's going to be minus 2x, and that's equal to 180. Subtract 230 from both sides, and I have negative 2x equals negative 50. And when I divide both sides by negative 2, I'm going to get a positive 25. Now, x is equal to 25. Let's see if this actually works. Given all the steps we have, there's a possibility of mistakes. This angle here is 25. This one is 25 plus 15, which is going to be 40. This angle here is 190 minus 3 times 25, and that would be minus 75. So that's going to leave us with 115 degrees. And then finally we have 3x minus 10. So 3 times 25 is 75. Minus 10 is going to be 65. So let's check it out. 115 and 65 add up to 180. Perfect. 40 and 25 equals 65 plus 115 again is 180. So this does work. So solve for x. X is equal to 25.